little, it's finally your time for Maths Monday. I am Looney, and with me in studio is Sikle. How are you, Sikle?
I'm good, Looney. How are you?
I'm good, thank you. What are we doing for the Mindsetters today?
Are we doing maths? Okay, no, we're doing some logarithms. We're doing log functions today.
All right,
mostly.
cool. Mindsetters, you heard it. We're doing logs for you guys today. Hope you guys are tuned in and you're ready to learn more and learn extra. Remember to download your show notes and videos and your schedules and learn.mindset.co.za. Remember to hit us up on Twitter and Facebook at Learn Extra, and you can enter the Test Yourself competition, guys. I will announce the winners of last week's show right after the break, or during the break, when we go to break, sorry. Yes, so remember to download your show notes for that, fill in the Test Yourself section, and then you submit your entry. Remember, the entry form is on our Facebook page, so you can check that out and enter, and you might stand yourself a chance to win 110 Rand Vodacom airtime. So with all that said, Sikle is going to give us the lesson.
Okay. Before I give you the lesson, I think we just want to give you your challenge question for today, grade 12. So your challenge question is, if log 2 base x, if log 2 base x is equals to log 64 base y, find y in terms of x. So towards the end of the show, we're going to go through your challenge question and see how many people are working back at home and who are getting it correct. Okay, now, so with our lesson for today, we'll be investigating the relationship between your exponential functions and your inverse functions. Now, start with the lesson. Right? Now, just a reminder of what we've been doing throughout from the first time we did functions. We explained that a function is a mathematical rule that maps an input value to a unique output value. And the domain of a function is a set of all input values, and you also need to know the range of a function that is a set of all output values. And our topic for today is when you're looking at the exponential functions and the relationship between the two, which is exponential and also the logarithms. Now, if you just define, this is just a traditional way of definition of a logarithm. If you given y equals to a to exponent x, then your log y base a equals to x. Now, most of you have done this, but if I can just make one practical example, which, for instance, if you're given that 2 to exponent x is 4, now, I'm asking you to solve for x. What is it that I have to put for x to get 4? So I'll raise something, base 2 to exponent something to get that 4. So in this case, you can have 2 to x equals to 2 to 2. Then the bases are the same left and right. So you drop the bases, you get to x is 2. Right. Now, we're looking at the relationship between the two. So when we doing logs, we've got to 2 to exponent x equals to 4. As the definition says, if you're given y equals to a to exponent x, then your log y base a is x. So in this case, you'll have your log 4 base 2 equals to x. And the rule that you've done beginning of this year, that we can raise 4. This is going to be base 2. 2 to exponent 2 base 2 is x, and then you've got 2 log 2 base 2 is x. So now log 2 base 2 is 1 times 2, then your x is 2. Now, can you see that there is a relationship between your exponents and your logarithms? But now, where are the logs helping us? They're helping us when we given, say, for instance, something that we cannot raise to the base, which was maybe given on the left-hand side. For instance, you're given 2 to x equals to 3. Now, in this case, it's highly, okay, what can I say now? English, Looney? Okay, you're not even listening. Okay, so you've got 2 to exponent x equals to 3, so I cannot raise 3 to base 2, so I can straight away use log. So this is log 3 base 2 equals to your x. It's just a quick recap on your logarithms, the relationship between your logs and your exponents. Now, if you've got your exponential function, y equals to 2 to exponent x, right? Now, for your x-intercept, you make y equals to 0, and then you try to solve for x. So it's not going to touch your x-intercept, so it's going to be asymptotic to your x, because if you put not equals to 2 to x, now x can be anything, all right? Now, for your y-intercept, you make x naught, so you get y equals to 2 to exponent naught, which is 1. So in a coordinate form, so naught and 1, that's why we have a graph like that. Now, if you were to sketch the inverse, now remember the exponential function, the inverse of an exponential function is your log function. Now, you just interchange like we've been doing last week. This was 0 and 1, so now it's going to be 1 and naught. Okay? So you'll have 1 and naught, and it's going to be asymptotic to the y-axis. As you can see, there's your graph. But we'll do more when we're getting into this lesson. Okay. Now, here you're given a figure. The figure shows the graph of g of x equals to a to exponent x. Now, your first question, you need to find the value of a. The next question, you need to work out what the domain is and your range of this function g. And you need to draw the graph of the inverse. And the next part, you have to represent, okay, does your inverse represent a function? And you need to explain, right? And the next one, give the equation of the inverse in the form y equals to. All right. Now, we look at this question now. Find the value of a. It is now given that y equals to a to exponent x. Now, how do I work out a? Now, this graph, it is drawn to scale. Now, if we were to look at the points on this graph, now, first of all, I know that this is 0, 1. And then this point, I also know that this is minus 1, 2. That is 1, 2, 3, 4. That's minus 2 and 4. Now, if I take a point minus 2, 4 and substitute, now I've got y and x. So it leaves me with one unknown, which is a, and that's what I'm looking for. So I'm taking minus 2, 4, right? Now I substitute. So I get 4 equals to a to exponent minus 2. Now I want a on its own. So I've got a to exponent minus 2 equals to 4. What is it that I have to do to get rid of that minus 2? Now I want to have a to exponent 1. Now remember, to get 1 there, just use different, okay? So if I multiply here by negative half, okay? Can you see that the minus 2 times the negative half, I get 1. But I have to, now remember, maths is a subject of balance. What you do on the left, you must also do it on the right-hand side. So this exponent I must also multiply by the negative half. Now next, remember, 4 is the same as saying 2 to exponent 2 times negative half equals to your a now, it's to exponent 1. Now that simplifies 2. If you multiply 2 by negative half, you get 2 to negative 1 equals to a. Now therefore, a equals to a half. So this is how we work out what our a is. Okay? Now, the next question says, find the domain and the range of g. Now remember, with our domain, we're working with the x. Okay? So now, if this is a continuous function, right? It's too close. It does not touch the x-axis. So it's asymptotic to the x. But you can have any x value, guys, throughout. So it starts from negative infinity all the way out to positive infinity. So now our conclusion here will be, right, the domain, our domain is x such that x is an element of negative infinity to positive infinity, or you can just say x is an element of your real numbers. Okay, right. So now we've got our domain, and our range, in this case, you've got your y is an element of. Now we look at our graph, the y values. So we go to your y-axis. So this is asymptotic to the x-axis. So we don't have any y up until we get to that point 0, right? But not including 0 because it does not touch the x-axis. So what we're going to say is, starting from 0 and up, then we find our range. So our range is y is an element of 0 to positive infinity. Okay. Now, next question. Draw the graph of the inverse. Okay. So draw the inverse graph to your y equals to half to exponent x. Now remember this graph, because it is given to us. Now, guys, very important. If you do your inverse, you interchange your x and y, right? Now, you look at your 0 and 1. Now, for the inverse, it's going to be 1 and 0. Okay? So we've got this point here. Now, another point that we have is minus 1, 2. So it means that for our inverse, it's going to be 2 minus 1. So I go to 2 and then minus 1. Okay? And the next point is minus 2, 4. So it means that the inverse is going to be 4 minus 2. So you go to 4 and then minus 2. And remember, it's going to be now, it was asymptotic to the x-axis. Now it's going to be to the y-axis. Now remember, with our inverse, it's reflection through y equals to x. So you've got, this is your new graph, and in this case, it's the inverse. So you'll do it nicely at home. Okay. All right. Now, so you've got the inverse there. That's our graph. Now, does the inverse represent a function? Explain. Now, remember, when we were talking about how do you tell if it is a function or not? Now, we said we do a vertical line test. And if it passes the vertical line test, it is a function. And to check if it's a 1-to-1, remember, we use your horizontal line test. Now, let's look at this graph. And, guys, this is not here. Okay? So now, if we do a vertical line test, now I'm erasing everything here, right? To do a vertical line test, can you see that this graph throughout, it passes the vertical line test? So I will conclude by saying, yes, this graph, okay, sorry, I'm writing on the wrong one. Does g2 minus 1 represent a function? The answer is yes, okay? It is a function because it passes the vertical line test. Okay, Luni, is it possible that we can go for a break?
Always possible.
Okay.
Mindset is we are going to take a break. Congratulations to Fortunate Mzimba, Peshka Sehoa, Moraka Machete for winning the 110 rand airtime from Vodacom from last week Thursday's Taste Yourself questions. Remember, if you want to be like them, enter the Taste Yourself question competition. All the details are on our Facebook competition. Let's take a quick break and we'll see you straight after this. Welcome back, Mindsetters, from that break. Shout out to Semekeleng, Poncho, Miso, Mukameli, Katlego, Tebo, Homlungisi, Tiamo, Letukutula. Come on. And a lady and Zamokutle. Thank you so much, guys, for tuning in. Sikle.
Thank you.
Listen.
That's toss. All right. Before the break, I ended up writing, and the pen was breaking up nicely. It was so romantic when you were saying yes, it passes through. It passes the vertical line test. Now, we needed to give the equation of your inverse in the form y equals to. Now, we look at the the graph, it is y equals to a to exponent x. So now the original function is y equals to a to exponent x, but we worked out what a is, so a is a half, okay? So now it means that this function, you've got y equals to half all to exponent x, right? So that is your function, so this is your g of x, so this is g of x. Now remember, when we need to work out the inverse, you interchange the x and y. So for us to get the inverse here, we're going to say now in the place of y, put x, then it's equals to 1 half to exponent y. Now, because I want to make y the subject of the formula, so I've got x equals to half to exponent y, so I'm going to say this is now log, the base is a half, so it's log x base half equals to y. So this is our inverse graph. Now, we move on to question number 2. With your question 2, it says, it's given that function of x, so f of x equals to 2 to exponent x minus 8. Find an equation of h if h of x is equals to f of 2x plus 8. Now, remember guys, if you're given f of x equals to maybe 3x, and I'm asking you to find f of a, so in other words, what I've done here is I've taken out the x and I bring in the a. So this is 3a. If I ask you from the original one, and I ask you to find f of maybe b plus 1, right? So what has happened here, I've taken out the x, I'm now putting in b plus 1 and then simplify. So this is 3 bracket b plus 1. So that gives us 3b plus 3 when you simplify that. Now, in this case, you need to find an equation of h if h of x equals to f of 2x plus 8. Now, let's write it down. H of x equals to f 2x plus 8. Now, in other words, because we're given that f of x is 2 to exponent x, where I see x, I'm going to sub in the 2x for that h of x. Now, let's do it. So h of x equals 2. Now, this is 2 to exponent x, so I'm going to have 2 to exponent now. In the place of x, I've got 2x, right, plus that 8 minus 8. So therefore, h of x, it's equals to 2 to exponent 2x. And now those two are like terms. What is 8 minus 8? Thank you, well done. 8 minus 8 is 0. Okay? So our final answer is h of x equals to 2 to exponent 2x. Now, our next question is, find an equation of the inverse in the form y equals to, so the inverse of h, so the one that we just did. So you've got h of x equals to 2 to exponent 2x. So remember, the inverse, so you go to your b, h of x is 2 to exponent 2x. So in other words, we have y is 2 to exponent 2x. Now remember, interchange x and y. So in the place of y, I'm going to replace it with the x, and in the place of x, I put y. So we have x is 2 to exponent 2y. Now I want to make y the subject of the formula. So you've got your log, the base stays as 2, then you've got your x equals to 2y. Now, because the question specifies, it says make y the subject of the formula. So you get your y is log x base 2. To get rid of that 2, it's multiplying, so you've got your 2y. So the undo of multiplication is division, so I'm going to divide by 2 throughout. So this is your inverse of h. Okay. Now, yeah, that's what we just did now. Okay. Now the next question, which is more or less the same as the one that we just did, it's given that f of x equals to 2 to exponent x, g of x equals to f of x minus 2, and h of x equals to the inverse of f. Write down the equation of g, okay? So you need to work out what g is, and h in the form of y equals to. Now, f of x is 2 to exponent x. I need to work out what g of x is, but I follow the instruction. They're saying g of x, to get g of x, you need to, in the place of x of the function f, you need to sub in the x minus 2. So now g of x will be 2. Now in the place of x, now it is x minus 2. And we need to simplify that. So now we have g of x is, now guys, with the laws of exponents, you remember that you have 2 to exponent x to minus 2 to exponent x minus 2 is the same as saying 2 to exponent x times 2 to exponent minus 2. All right? And now that is 2 to exponent x times, take this to positive exponents, this is the same as 1 divided by 2 to exponent 2, which is 2 to exponent x all divided by 4. So this is your g of x. Okay, now you need to write down the equations of g and h. So we've done g, we need to work out what h is. And h is the inverse of f. Okay. Now, f is given as 2 to exponent x, right? So you do the second part, so we can call it b. Right, we need to work out h. So h of x is the inverse of f, but we know that f is y equals to 2 to exponent x, and to work out the inverse, interchange x and y, so you get x is 2 to y. Therefore, your log, okay, I can write it here. So this is log of the base is 2, then you get your x. So in the form y equals 2, so this is your inverse of f. Okay, now I hope that helps. Now next question, which is your now question number 4. It says the graph of p of x equals to a to exponent x is sketched below. The point minus 3, 8 lies on the graph. That's very important. The point minus 3, 8 lies on the graph. So this point t is also part of your exponential graph. Now, calculate the value of a. That's question number 1. Write down the equation of the inverse in the form of y equals 2. And next, for which values of x will your inverse be greater than 3? And the next question, write down the equation of q if, it looks like a q, if q is a result of p shifted 3 units to the right. Okay? Now, let's start with finding the value of a. It is given that p of x is a to exponent x. So you've got p of x is a to the x. Now, there's something important that's given to us. Says there's a point on that graph which is minus 3, 8. So the coordinates are x is minus 3, y is 8. So we can substitute. Okay, let me just do it here. Y is 8 equals to a to exponent x is negative 3, right? Now, I need to get rid of that negative 3. So what do I do to get a 1 there as the exponent? So I need to have a to exponent 1. Now, I'm going to multiply the right by a negative third. So what I've done on the right-hand side, I must also do it on the left-hand side. So this is minus half. This is now 8 to exponent negative third, and you can write 8 to base 2, so this is 2 to exponent 3 times negative 1 over 3 equals to, now that is your a. So therefore, a is 2 to exponent negative 1, which is a half. So you've got a equals to half. Now, next question, write down the equation of the inverse in the form y equals 2. Now, we already know that y equals to half all to exponent x is the equation of p of x. Now, we need to work out the inverse of this graph. Now, so we're going to have x equals to half all to exponent y, then log of the base is a half, x is y. So the inverse will be y equals to log base half, log x base half. Now, next question. It says here, for which values of x will p to minus 1x be greater than 3? Now, this question, we're going to do it both ways, both the graph and also algebraically. Right, now, just erase this. We can sketch this graph, our inverse. We know this, that this point here is not 1, because if we substitute by naught in the equation y equals to half to exponent x, if you put a naught there, 1 over 2 to exponent naught, anything raised to exponent 1, in this case you get as a 1, so it's naught and 1. So in other words, we're going to have 1 and 0, right? Now, the point there at the top, it's minus 3, 8, so it means that I'm going to have 8 and minus 3. So that's going to be 8 will be somewhere there, and minus 3. And it was asymptotic at the x-axis, so now it means our graph will be asymptotic at y. So we get that graph. This is our inverse. Now let's go back and interpret our graph. The question here says where our y values are greater than 3. Sorry, this one here, it can't be greater than 3. So this should be your p to minus 1x is greater than negative 3. Okay, so we have negative 3 is here, right guys? So you've got negative 3. Now the y values are greater than negative 3 from that point and up, but we want to work out the x-axis. Now if you go to your x-axis, so you've got starting from here going down, but before the naught, can you see that our y values will be greater than minus 3, the region between 0 and 8. So if we look at the graph like that and interpret where is our y of the inverse greater than negative 3, we have x between 0 and 8. So how do you write that? So your x should be between 0 and 8. Now, I know some of you will be tempted to do it algebraically. Then your p to minus 1x, we've worked it out. So it is p minus 1x is greater than negative 3. Now, watch, your p to minus 1x is this graph, which is given log x base half. So we've got log x base half, okay, greater than minus 3. Now, remember, with your logs, you can work from logarithms to your exponential. So you can change from exponents to logs and vice versa. So if I take this to exponential form, I'm going to have half to exponent minus 3. This is greater than x. Now remember, applying your log rules from logs to your exponents. Now, to simplify that, I can put the x on the left-hand side. And so I've got x should be less than, half is 2 to exponent negative 1, but all to exponent minus 3. So x must be less than 2 to exponent 3. So x is less than 8. Now, remember, so we've got only one solution here at the moment. So x should be less than 8. Now, we know that our restriction, your x for the inverse, it should be greater than 0. So in other words, from 8 and all the way up until we stop at 0 at the origin. So therefore, our solution, your x should be less than 8, but remember, it must not be less than 0. So that should be greater than 0. So this is our solution for this problem. Now, for which values of x will your inverse, your y values of the inverse be greater than 3? Now, next, write down the equation of q if q is a result of p shifted 3 units to the right. Now, remember, if you shift to the right, you minus, shift to the left, remember last year, you add. So on the x, now, so we've got this, where is p? P is, okay, got it. P of x is half to exponent x. Now we're shifting 3 units to the right. So this is going to be, now your q x will be half, shift to the left, so this is x minus 3. And then that you can leave it that way. So your q of x equals to half all to exponent x minus 3. Loni, over to you. I think it's a mortar.
Yes. Shout out to Prishka Tabang Esihle, Mfundo Mukwena Katla Hotumelo Basana Mariah, Mfundo Gentando, Maps, Kamuhelo, Semekeleng. And then a special shout out to Ayanda Trevor, who's asking me to say hi to his schoolmate from Reunion Secondary School, Isipingo. Thank you so much for that, mindsetters. Let's take a short break and we'll see you straight after this. Hi there. Welcome back. Still doing maths with Sikle, so I won't waste your time. Sikle.
Guys, I'm also not going to waste your time. You can do it on your own. All right, I'm joking. Right, so I'm going to do the challenge question now. I'm assuming some of you have got some answers to the challenge question. Luni, can you just check if anyone has responded on the challenge?
Okay, I'll do that. You can just.
Okay, I can just.
Yes.
Do it anyway. Okay, just do it. All right, so now you're given that log 2 base x equals to log 64 base y. You need to find y in terms of x, right? So you need to work out what y is. So in simple terms, you're going to have y equals to da-da-da-da, but with an x on your right-hand side. Or
we've got people that tried it.
People tried it?
Yes.
Okay, let's see the trials.
Y is equal to x to the power of 6 is their answer.
Okay. Y is x to the power of 6 is their answer.
Yes.
All of them?
Yes.
Okay.
All of them.
Right, that's impressive. So people are working out there. Eh? Which area are they from? South Africa. Okay, thank you. Right, so you've got, if log 2 base x is log 64 base y, you need to work out what y is in terms of x. Now, one of the ways that you can do this is, remember, your laws, if you've got log of p base q, this is the same as log p all divided by log q to any base. You can have c there. So in this case, I've got log of 2 all divided by log of x, and the base in this case is 10. This is log of 64 all divided by log of y, right? Now, next, my main aim is to get to when y is the subject of the formula, all right? So, next, I'm going to cross multiply. So I'll have log 2 multiplied by log y is log 64 times log of x. Now, guys, remember our goal is to get y on its own. So it's multiplying by the log 2. So in this case, I can now divide by your log 2 on both sides. So I'll have log 2. Then the log 2 divides the log 2. So I'm left with log of y equals to log 64. Now remember, I can write 64 as 2 to exponent 6. So this is log of 2 to 6 times log of x, all divided by log of 2. Right? Now next, this is log of y equals to. Now remember this rule. If you given log x to exponent c base b, this is the same as c log of x base b, right? Now, so it means that with this one here, log of y will be exactly the same as 6 times log of 2 times log of x, all divided by log 2. Now, next, log 2 tells the log 2. So log 2 divides log 2. So you get log of y it's equals to 6 log x. Now, we're almost there. So you've got your log y equals to. Now remember, you can take this back as an exponent. So this is your log of x to exponent 6. Now, guys, remember, if I've got the log, the base is the same left and right. Now, in this case, you've got base 10, base 10. So I can drop the logs, okay? So therefore, y equals to x to exponent 6. Okay, so that's one of the ways to look at this, and well done to the guys who've got y equals to x to exponent 6. And if we look at the solutions of some other people, they're saying you can, because these two are the same, so your log 2 base x is the same as log 64 base y, which a quicker method to look at this is, let's get some, okay. Now, you're going to try it at home, right? The second way of looking at this is to say maybe let k equals to your log 2 base x, and let k again be equals to log of 64 base y. And this is the same as log 2 to exponent 6 base y. So k is that, k is that. Now, if you take it from log form to exponential form, so this one you'll have your x to exponent k is 2. That's your first equation. And this one is your second equation. Because you've got 2 equals to x to exponent k, you can now take this and substitute there. So you'll have your k is, now you have 2 you've worked out what 2 is. So 2 is x to exponent k. So this is log base y. This is 2 to exponent. You've got your 6 there. Then this is 2 is x to exponent k. So this I should take it out. That is out. Now you have your 2 is x to exponent k. So this is going to be x to exponent 6k. Now if you were to take this to exponential form, this will be y to exponent k equals to x to exponent 6k. Therefore, y will be x to exponent. Now, to get rid of that k, you times by k, 1 over k throughout, so y will be x to exponent 6. So whichever way you did it, the final answer will be y equals to x to exponent 6. Right. Now, thank you guys. So you move on to question number 5. The figure below shows the linear relationship between log y and log x. And you're given a point 2, 3, and it passes this function, this linear function, it passes through 0 and 0. Now let's try and make this thing a bit simpler. If I give you something like this, and this is your y, this is your x. Sorry. And then I give you that, and say this is the point 3, 6. Okay? Now maybe this one will say it's 3 naught. Now we need to work out the equation of this graph. You in metric, you all know that we need to get the gradient of this graph. Okay? So this should be minus 3. Sorry, this is on the negative side of your Cartesian plane. So you've got 3, 6 and minus 3 naught. So you need to work out the gradient, which is the change in y over change in x. So in this case, you get your 6 minus naught divided by 3 minus 3, which is 3 minus minus 3. It's plus 3. So you get 6 divided by 6. So the gradient is 1. So m is 1. Then you use your y minus y1 equals to m into x minus x1, and you take any point on the graph. So y minus 6 is 1 bracket x minus 3. In this case, y is x minus 3 plus 6. So y is x plus 3. Right? So in simple terms, we need to get the gradient and the y cut. But in this case, we're looking at the relationship between log y and log x. So the gradient of this graph, so the gradient will be change in y over change in x. So you've got naught and naught here. So the gradient will be your 3 minus naught divided by 2 minus naught. And we get 3 divided by 2. So the gradient is 3 divided by 2. Now if we had y-axis and this is x-axis, then our equation was going to be y equals to 3 over 2 x plus naught, which is your y cut. But in this case, we're looking at the relationship between your log x and your log y. So log y replaces, it stands in the place of your y-axis, and your log x is in the place of your x-axis. So in this case, you therefore write it in the form y equals to mx plus c. So therefore, y, and in this case on the y-axis you get log y equals to your gradient, you've worked it out, it's 3 over 2, and your x is your log x plus naught, which is your y cut. So in simple terms, you have expressed your log y in terms of your log x, so therefore your log y, it's equals to 3 over 2 log x. Now, the next question says, hence, write down y in terms of x. Okay? Now, we've worked out that your log y is 3 divided by 2 log x. Now, I want to make y the subject of the formula. So I've got log y equals to 3 divided by 2 log x. So this will be your log y equals to log x to exponent 3 divided by 2. Now watch. The base on the left is 10. Base on the right is 10. You can drop the bases because the base on the left-hand side is the same as the base on the right, so therefore y is x to exponent 3 divided by 2. Any questions so far?
Yes. This one's from Rorisang, and she's asking. Think it's a she. She. Determine the inverse of y is equal to x squared minus 2x minus 8.
What? X squared. I need a clean page. Y equals to
X squared minus 2x minus 8. Determine the inverse.
we need to work out the inverse here. This one is playing with us. Right? You interchange the x and y, right? Now watch. The catch is going to be here because you'll be having two y values. Okay, let's try it. So you're going to have your x is y squared minus 2y minus 8. Now, we've got x plus 8 equals to y squared minus 2y. Now you need to make y the subject of the formula. If you had a note on the left-hand side, then you would say y bracket y minus 2. So this can be done algebraically. The only thing that you can do on this one is you work out your graph, and in this case, you've got the quadratic graph, so y equals to x squared minus 2x minus 8. Your y-intercept in this case will be minus 8, so you've got minus 8, okay? So it's not in minus 8. And your x-intercepts, you have your x equals to 4, so just quickly, so 4 and minus 2. And your turning point will be 2x equals to 2x is 1. So you've got your 1. Okay? So I'm hoping you're doing the same thing at home. So you've got x equals to 1. And you sub in your 1 here, you get 1 minus 2 minus 8, you get a minus 9. So this is negative 9. This is your graph. Okay? Now, watch. You have to do some restrictions on this graph. In order for this to have an inverse, you can't do this one algebraically. No.
Okay, cool.
Okay, another question.
And then from Morongo is asking if you could please repeat question 4D.
Question 4D. Question 4D. Oops. Right. Okay. Question 4D. All right. Write down the equation of Q if Q is a result of P shifted 3 units to the right. And we're saying if it's 3 units to the right. Now, if I've got an example here, y equals to maybe your 2 bracket 2x. Now, if I'm saying shift this 5 units to the left, right? So you shift that 5 units to the left, so you plus here in your x. So this will be y equals to 2 bracket x plus 5. So if you shift to the left, you're going to say x plus. Shift to the right, it's going to be x minus. So this one, you'll have your y equals to 2x plus 10. Now, this graph, we had y equals to half to exponent x. So you've got y equals to half to exponent x. We need to shift this 3 units to the right. And we're saying to the right, you minus, so you get your x minus. So in this case, I've got x. So in the place of x, I'll have y equals to 1 over 2 all to exponent x minus 3. So this is how we got your graph resulting from shifting to the right. Now, I think we are left with a question here. Now, our question 3 says, the graph of f of x equals to minus bracket x plus 1 squared plus 4, and g of x equals to a times 3 to x plus q as sketched below. A and b are the x-intercepts of f, c is the y-intercept of f and lies on the asymptote of g. The two graphs intersect in D, the turning point of f. Now the first question, find the coordinates of a and b. Now guys, let's look at a and b. What is a and b of your parabola graph? So this is these two are your x-intercepts, and the graph is given minus, so y is minus bracket x plus 1 squared and plus 4. So that is plus 4. Now you need to work out your x-intercepts, and remember guys, for x-intercept you make y equal to 0 and solve for x, right? So for x-intercept, let y equal to 0. So you get 0 is negative bracket x plus 1 squared plus 4. So now if I need to solve for x here, I can either multiply out and get x squared plus 2x plus 1, or you can just take this across, so you get your x plus 1 squared is 4. Now I will square root on both sides, so this is plus or minus. Remember, if you introduce the square root yourself, so you get x plus 1 is plus or minus 2. Then you get x is minus 1 plus 2, or minus 1 minus 2. Then you get x is 1 or negative 3. So therefore, the coordinates of a and b, remember a is on the negative side of the x-axis and b is on the positive side. So therefore, a is negative 3 naught and b is 1 and 0. So those are your x-intercepts. Now next, they're asking you to find the equation of g. Now, what is g? G is given, g of x equals to a times 3 to x plus q. So, y equals to a times 3 of x plus q. Now, your q is the horizontal asymptote of that graph, okay? Right, so now, right, looking at our time here quickly, this line is just moved, okay? So it's supposed to be through that C, so that this will be your asymptote to that graph, which is your exponential graph. Now, quickly, we need to work out what C is, okay? All right, so now, guys, because of time, let me just tell you what you do at home. So you need to work out what your C will be your Q of that graph. We'll continue next time.
All right, thank you so much for tuning in, Mindsetters. From us, it's a goodbye.